Hey everybody, Sean Tierney here from the Automation Blog and School, and in this episode of the Automation Podcast, I meet up with Sean Foley from Banner to learn all about their new technology, Snap Signal. Sean, thank you for coming on the Automation Podcast and taking time out of your busy schedule to sit down with us and talk to us about Snap Signal. I saw this awesome graphic you guys had on LinkedIn, and I'm like, we got to get Banner on to talk about this. It looks like some really cool technology. So, with that, let me turn it over to you. But before you jump into your presentation and telling us about this, could you tell the audience a little bit about what your position is at Banner?
Absolutely, Sean. Yeah, it's great to be here. I'm a business development manager at Banner Engineering, and I've been involved in both a little bit of product management, but also business development for this new group of products from Banner Engineering called Snap Signal. And it's really, really great to be here. I've been following the automation blog for quite some time. I love your content, so it's great to be here.
Oh, thank you so much. Really appreciate that.
And yeah, so very excited today to kind of talk about Snap Signal. I just wanted to give you an overview, Sean, of kind of what Snap Signal is. And if you have any questions, just feel free to stop me along the way. But it's something that I'm really, really excited about. And it's a portfolio of products. So to kind of tell you that in advance, it's not just one individual product, it's a portfolio of IoT enabling products. And IoT is something the word's been around for quite some time, but it's a portfolio that we created, and the initial question was why we created it. Well, the big thing is condition monitoring and predictive maintenance saves money. And what we wanted to do is what we really wanted to come up with is an easy to deploy solution, not just for brand new equipment, but in particularly for existing machines and legacy equipment. There's so much equipment out there that's not tapping into the potential of IoT. So many customers think that IoT can only be applied to new machines, brand new equipment. But what we found is most of IoT's value is actually applying it to a lot of old equipment. There's so much great equipment out there that's functioning and that's working well, but could be working even better by deploying IoT solutions. So what is kind of a Snap Signal? In a nutshell, it's our products, it's converters, it's controllers, connectivity, and software to get your sensor data to the cloud. And from there, you can make better data-driven decisions. What we'd like to call this data is actionable data. Um, and so what this is going to allow you to do, it's going to allow you to unlock more potential of existing devices on machines. It's going to allow you to improve the overall equipment effectiveness of your existing equipment. It's going to allow us to do things, we're seeing it all the time where a Snap Signal is being applied, where it could be used to reduce downtime significantly. By just doing small, scalable IoT implementations that don't have to be complicated, we're seeing a lot of traction and a lot of success with Snap Signal. So that's what it's designed to be. It's designed to be easy. So how are we doing this? Well, in a nutshell, using Snap Signal products, we're going to be able to convert existing sensor signals and new sensor signals to a unified protocol, so they're all talking the same language, and we're going to bring those sensor signals to a controller. And from there, we're going to be able to distribute that data to monitor machine conditions. You could send that data to the cloud, you could send that data to a PLC, or you could send that data to a SCADA. So it's all about capturing existing and new sensor data, converting that sensor data to a unified protocol, so it's all talking the same language, and then distributing and consuming that data in a SCADA, PLC, and cloud. So we're going to talk a little bit about that and kind of dive a little into some of the products. So a few stats that really stuck out to me, Sean, is that the average age of manufacturing assets in the United States is 20 years old. So there's a lot of equipment out there that's been installed for years and years that's working quite well for a lot of end users. But we're also seeing an unprecedented amount of interest in IoT, with 46% of companies planning to deploy IoT technology in the next 3 to 5 years. So companies are really starting to look at it, IoT, seriously. It's no longer a dark art. People are actually starting to use it more and more exponentially. We're also seeing the same in spending. You know, the average spend of in IoT equipment. Um, and one of the things we discuss with end users when they're looking to start deploying IoT is helping them overcome some common myths. And one of those myths is that IoT always requires greenfield applications or new machines. You could only have this cutting edge technology applied to new equipment. And what we found is the opposite. We found that although IoT is certainly a great solution for those new pieces of equipment, most of IoT's value we found is coming from improving brownfield sites, improving existing and legacy equipment that's installed all throughout the United States, all throughout the world. So another thing we've also run into is there's a myth that IoT is always going to be extremely expensive, always going to take a huge amounts of planning and time and effort. And then this leads to many companies interested in adopting Industry 4.0. They're wary of these kind of massive enterprise-wide commitments, consulting engagements, and also, frankly, bringing their systems down for large periods of time to deploy this new technology. And so what we're trying to do with SnapSignal, it's a portfolio of products, is to offer a flexible, scalable, simple portfolio of products that allow you to pilot an IoT concept quickly, establish those savings and success, whether it be improving your equipment effectiveness, whether that's eliminating downtimes or significantly reducing downtimes. And then once you're able to pilot that concept successfully, you could scale. You could apply it to more areas in your factory. So let's kind of talk more about that. One of the big things about SnapSignal is that it's all about being able to apply IoT technology to your existing assets and machines. And this is big without ripping and replacing your entire control system. So typically, we're not going to be diving into your control panel. We're not going to be ripping and replacing or reprogramming your PLC. We're going to be talking about it a little bit, but SnapSignal is designed to be an overlay. We're working in parallel. We're not going into your control cabinet and reprogramming your entire PLC. And that's a huge part of SnapSignal, is that we're not doing that. And what this is going to allow us to do is it's going to allow us to minimize risk by testing ideas on one machine and prove value without large investments of time and money. I'm going to talk about some applications a little bit. And then the thing I like to emphasize is just the breadth of products. SnapSignal has provides all the hardware and software you need to monitor just about any type of device and sensor. So here's the animation you saw, Sean, on LinkedIn. This is what we like to call the IoT data elevator. And this is something that we show to really encapsulate what SnapSignal does. Sometimes it's difficult when you have a full portfolio of products to visualize what's going on. And kind of what you see is the SnapSignal data elevator. And on the very bottom capture layer, you have all these different types of sensor signals. You have analog, you have current transformers, you have discrete sensors, you have lighting products, for example. You have, this is one of the QM30's vibration and temperature sensors that are typically mounted on motors. And we also have a temp and humidity sensor, which is this one right here, this barrel sensor, used to measure the temp and humidity of an environment. So you have all these different sensor signals doing different things. And what SnapSignal, what we're going to do is we're going to convert all of these sensor signals that may be on a machine already, or you want to add to a machine, and convert them over to a unified serial protocol with these they're called our S15C converters. And our S15C converters are about the size of a AA battery, and they just have two double M12 connectors on either end, and you just plug it right into your sensor or anywhere in line with that M12 connectivity for ease of use. And what this allows you to do is allow you to get all these different sensor signals talking the same language before going to what's called our DXM R90 industrial controller. And we're going to kind of do a little bit of a deeper dive on some of these products, but what it's all about is just getting all these sensor signals talking the same language. And from our DXM R90 controller, you're able to bring this data either to a PLC via there's a decode Ethernet port on the bottom right there. You're going to be able to send that data to a PLC. You're going to be able to send that data to a SCADA system, or you're also going to be able to push that data directly to the cloud, whether that's Banner's own cloud data services called Banner Cloud Data Services, Or if you wanted to push it to AWS, for example, via something called what's called MQTT. And so it's designed to be a full portfolio, scalable portfolio of products that makes condition monitoring, predictive maintenance of your assets really easier and much more scalable than what was previously done. We developed SnapSignal with conversations with a lot of customers, and they were struggling. They didn't have a single scalable solution in place, and so that's how we came up with SnapSignal products. So some of the key areas where it's typically applied is in condition monitoring of assets, whether that's a motor, for example. You wanted to monitor the vibration and temperature of a motor. That's a really critical one in a lot of factories. Or it could even be something like tank level, where you want to monitor the level of your tank and receive text message alerts from the cloud if your tank level goes below a certain threshold. That's something as simple it could be. It could just be adding a couple of sensors to a machine, and you could get really significant returns of investment and save significant amounts of time, but just doing a very small instance of IIoT. We also apply it a lot in OEE applications, and we're going to talk a little bit about that in a little bit. But here are some of the key areas where we're seeing the SnapSignal product family being used. So if we're going to dive into some of our converters, the converters themselves they function simply. They convert basic signals from one signal type to another. So we're able to, with our converters, to take in signals like discrete sensor signals, analog sensor signals, whether it's a 4 to 20 or a 0 to 10 volt, whether it's a discrete, if that's an NPN or PNP proximity sensor, for example, if it's a temperature sensor input, we're going to be able to convert those to smart networks like IO-Link and Modbus RTU. And these are very plug and play. They require minimal setup. You just plug it right in to your sensor or anywhere in line for ease of use. And what's important to note is that just the breadth of converters we have. I think we have more than my slides can keep up. We have over 30 converters available, and they function very simply. And they're about the size of a AA battery. So if you say you had an analog sensor, you wanted to convert it over to Modbus RTU or to IO-Link, we have a converter in stock for that. Here's kind of an application talking about that tank level, for example. With our converters, for example, we're able to tap into existing sensors. And this is a big thing for a lot of end users who are looking to deploy SnapSignal and deploy IoT. Sometimes they don't even necessarily have to replace their sensors that they have installed in their equipment. So here we have some analog sensors just monitoring the tank level mounted above some tanks. And what we're able to do is we're able to take that 0 to 10 volt signal and then convert it over to, in this case, a unified serial RS-45 protocol, and then bring it back to our DXM 1200 controller, and then push that data to the cloud. And in the cloud, in this particular application, they wanted to get text message alerts if their raw material fell below a certain threshold. And so they wanted to notify personnel throughout the factory with a text that the liquid in their tanks was running low. So what's kind of powerful about this as well is if you have these sensors already installed, talking to your existing control system, what you could do is if you wanted to harvest that sensor data without disturbing your existing controls, you could use something as simple as an M12 parallel wired splitter to still have that sensor signal going back to your PLC. And what we're doing is we're simply using that parallel wired splitter. One branch is going back to your PLC, and then one branch is going into this converter. And so it's a way to non-invasively harvest sensor data that's already there to bring that into a SnapSignal network and then bring that data to a cloud. So in a lot of cases, we're able to harvest sensor data that's already installed in the machine by just using a parallel wired splitter, a converter, and then getting that data to the cloud. So in a lot of cases, it's not even a matter of even replacing sensors.
And I think that's really appealing because It's a very huge concern when you see banks exposing billions of dollars to hackers. How can a plant out in East wherever compete with a bank's security, right? So they don't want to connect their PLCs to the internet, to the cloud, because they know if the people who do this professionally are always getting hacked, that trying to protect their control system is going to be a daunting task. And so being able to split there right at the sensor and say, hey, we're not going to disturb or expose the control system. That is going to continue to be behind, the air gap between the outer world and the control system. And now we take that sensor value, which is outputted from the sensor. It's not like a hacker could come in and reprogram it. And we will
Exactly
send
right.
that up to the CDS so that I can just use the banner system to create that whatever I need to do, and I don't have to become the SCADA or PLC guru, if I'm just trying to get some more data up into the cloud. So and
Exactly.
again, I'm not to say that you guys you said this already that you do integrate with Ethernet IP and Modbus and all these other standards and SCADA and HMIs. That's all there as well. But I can definitely see the appeal from that other side.
For sure. And the thing, one of the other big appeals is on the downside time. It's something that's very quick to install, just a parallel wired splitter and a converter. And we're able to do a very quick, seamless IoT implementation, really quick. You could do it over lunch, harvest the sensor data that's already there, and have data being brought up to the cloud. Um, and so that feeds in really nice, Sean, to kind of the other part of it, and that's the DXM R90 industrial controller is what you see here. And so like what I mentioned before, and what you highlight is you could push that data from all these different sensors to the cloud, whether that's AWS, for example, or Banner's own cloud, which is called Banner Cloud Data Services. We could also send that data via that decode Ethernet port to your PLC or your SCADA. It talks all those industrial languages: Modbus, TCP, Ethernet IP, and Profinet. And so I like to think of really this product as the consolidator. It allows you to gather all these different sensor signals throughout your factory, throughout your machines, um, getting it into a single pipe, and then pushing that data out to the world, whether that's to a cloud via HTTP push methods, or whether that's to a PLC or a SCADA via what's Ethernet IP, Profinet, and Modbus TCP. So you could also talk to AWS, for example. It has MQTT as well.
Okay.
Um, and what's kind of powerful in a lot of cases with this controller is by converting these sensor signals over to a unified serial protocol, you could have multiple sensors going back to a single port on the DXM R90 industrial controller. You could have, instead of just having one sensor going to each port on the DXM R90, we've seen applications where people have well over a dozen sensors being pulled into a single port on the DXM R90 just by using trunk and branch methods. And I have a slide that highlights that in a little bit.
Okay.
But by being able to pull in a lot of sensor signals, you could just use a one DXMR90 and have a ton of sensor data being brought from your machines, either to your PLC or your SCADA system.
Now this question it may be a little early to ask this, but and I don't want to steal your thunder, but does a single model number support the different protocols, or do I have to order a different controller whether I'm doing Profinet or Ethernet IP or Modbus TCP, or is how does that work?
It's a great question. It's a single part number, so it'll support
Oh,
all
that's
of
awesome.
those. It'll be multi-protocol.
That's awesome.
Yeah. And so just to kind of highlight some of the features on it, it's the four client ports there at the bottom. There's also a port there on the left. And what's really powerful about this port is you could use it as a fifth client port, but you could also configure that port to daisy chain multiple DXMR90s. So you could have multiple DXMR90s in a line talking to each other if you wanted to, say, have a daisy chain multiple DXMR90s, for example. It has LEDs at the bottom for status, error status indication. And then it also has that power port, and also if you wanted a daisy chain, you could provide power across a single line. This operates on 24-volt DC. And then lastly, we just have that decode Ethernet connection, and it talks that Ethernet IP, Modbus, TCP, and Profinet. So here's a quick little video, Sean, that highlights just how quick it is. Here's where we're harvesting a sensor data, just showing how quick it is. We're going in there with a parallel wired splitter, plugging it into the sensor that was already installed. One branch is going back to your PLC, and one is going back to the small S15 converter that's taking in that discrete sensor and converting it over to that unified serial protocol. And here we're just plugging it into a DXMR90. And from here, we're able to send that data via HTTP push methods on that decode Ethernet port. And we're just going to push this data from this sensor counting boxes to a cloud platform. In this case, it's Banner CDS. And as you can see, we're able to set up some very nice dashboards. Banner has a lot of flexibility with how we can do dashboarding. We could set up very simple text message alerts if the throughput goes below a certain threshold. We could set up performance images like the one in the upper right here that shows with widgets. So we have a lot of flexibility. And as you can see, that was a quick installation with just using one sensor. Just using one individual sensor, we're able to get a lot of insight. That's particularly is an OEE application.
Now, before I have a question, but before I ask it, just for the audio only audience, maybe you're driving, listening on your commute, the controller is about the size of, I would say, two cell phones stacked on top of each other, and all the connectors look like they're M12. So you had the four on the bottom, the one on the left, and then the two on the right, one of which is the Ethernet port. And it had just had an array of LEDs on it for indications. So very, very slim. And the splitter was just it looked like an M12 splitter. I mean, there's nothing special about it. It was just a standard splitter that you guys put right onto your sensor. In this case, it was a photo eye, and just sent one back to the PLC and the other one into the AA size converter that converted the signal and then went into the controller. Did I get all that correct, Sean?
You're exactly right. You're absolutely right. And yeah, the controller is really compact. It's also IP65, IP67, IP68, so you can just mount it right on your machine. It's 90 millimeters in length, so it's really quite compact. And so
Now that converter, right? So if we're talking about the converter, typically you don't want to run an analog or digital signal too far, but the converter is converting it to, let's say, a 45 style communication. So you can go thousands of feet, right, after you go to the converter.
exactly. That's the really powerful thing about that serial RS-45 protocol. Once it's converted over to that unified protocol, you could have really long lengths of just standard M12 cables bringing your sensor data back. So that's another really nice feature that you brought up there. By converting that over, you could have really long lengths of cable from your
And it can
sensor to the controller.
and you can use T's. I mean, it's a daisy chain. Correct me if I'm wrong, but 45 you typically can daisy chain, so you can use as many T's as you want to connect. Well, you're showing it on the picture, but for the audio only audience, this doesn't have to be, you have to run to every single sensor. You can tee them together.
Exactly right. So that exactly. So being able to use just one of those parallel wired M12Ts, you could have multiple dozens of sensors going back on that same branch, going into a single port on that controller, a single M12. So you could have, whether it's discrete analogs, vibration sensors, temperature sensors, or a mixture of all on that going back on that single branch, going to a single port on the DXM R90. And that's really powerful, being able to bring in not just one sensor signal, but multiple sensor signals, multiple different sensor signals to a single port on the DXM R90. And so that's another great feature as well. That's a great one to bring up.
Excellent. That's awesome.
So here's kind of another slide that highlights just an OEE application. We're harvesting, a bottling application where they have some discrete sensors already installed, already talking to their PLC or their control system. And what we're doing is we're just simply using that data that's already there, using a parallel wired splitter, and then converting that over to a unified serial protocol with those converters. And then the other branch of that splitter is just going back to their existing control system. So the existing control system doesn't even see the converters, the other technology. It's an overlay, so it's not even disturbing it in any way possible. And we're able to just harvest that sensor data, and then create very powerful dashboards. Um, and then from there, they can make better decisions, whether it's scheduling decisions on their bottling or conveyor applications. They're able to monitor throughput from on their machines from anywhere in the world directly on their cell phone.
Now, let me ask you this. I mean, it makes sense that you would have sensors coming into the splitter and then one going stay into the control system, the other going um, to the snap signal controller. But it also looks like you were intercepting on this slide, you were intercepting the signal from the PLC that was driving a stack light.
Exactly. So we're able to take in that sensor signal as well. And that's another powerful thing you could do is you could take that signal for that light, whether it's turning on a red or a yellow or a green LED, you could use that data as well.
Yeah, so
And
it's the same concept, but now we're grabbing the PLC's outputting to a stack light, and we're going to grab that data as well with the same type of splitter. So we can not only know what the sensors are doing, but we can know what the PLC's telling the operator via the stack light. That's pretty cool.
yeah, exactly right. Yeah, thanks for pointing that out. It's the flexibility of it's the key, and it's something that's so flexible that you could do so much with it. And kind of highlighting some of the other things it could do is even like raw material monitoring a roll diameter, for example. You could have some analog sensors mounted above some rolls, and what we could do is take in that sensor data, convert it over to unified protocol, and we have also have these WLS15 lights that you could also mount directly on your machine for local indication. So if you wanted to have on that same branch, if you had analog sensors mounted above some rolls monitoring your raw material, and you wanted to bring that data, that 0 to 10 volt or 4 to 20 milliamp data, uh, and set up dashboards in the cloud, you could certainly do that. You could have multiple analog sensor signals converted to a unified protocol with those converters. And you could set up very simple dashboards. You could set up text message alerts, for example, but we also have that flexibility to add local indication on a machine as well.
So this is where the banner controller is controlling that indication. So that's a right back out to the field.
Right, right. So you get that 4 to 20 signal, and we're able to set up a very kind of a visual factory element to this as well, where they could see a fluctuating light right next to the roll diameter that's showing visually to the operators on the plant floor, hey, you might be running low. And also they might get a text message from Banner CDS alerting them that their roll diameter, their raw material is falling below a certain point. And that's another one we've seen is where monitoring raw material and a lot of applications, if you run out of raw material, you're no longer producing revenue. So it's something that
Yeah.
it's important to track and just know when you're running low. So you could set up even things like automatic reordering, for example. And
You
so
know, I was just going to say another thing I've seen end users run into is they'll get a machine in and they're not allowed into the code. And so they still want to provide some visualization for their employees, but they don't have access to that PLC that's on that piece of OEM equipment. And I think this would be perfect for that. Say, okay, well, let me just split the sensors off. I'll bring it into my banner controller. And then if I need to display a level or an indication, I can do that. And I'm not touching the OEM's PLC. I'm not touching their code. So go ahead. I'm sorry. I
exactly
didn't mean to
right.
interrupt.
Oh, such a good point. You're exactly right, and that's where we're kind of seeing a lot of success. The local indication side of it as well. We're not disturbing their existing control system with it, but we still are able to increase uh, the effectiveness of an application without even diving into their controls, which is a great point. And what's also important to note is I've highlighted a lot of applications where we're harvesting existing sensor data that's already on a machine. But the key thing is we could certainly add more sensors to this network to improve it even further. Whether it's if you wanted to add in this application, maybe there's motors, maybe there's temperatures of certain assets that you want to track. You could add new sensors as many, you could add new sensors to this infrastructure very easily just by using either tying it into that branch going back to that port or using any of those four other ports that are being shown in this application. So you could add vibration sensors, you could add temperature monitoring sensor capabilities, you could add discrete monitoring, all these different sensor signals. So you could use sensor data that's already there, that's already being used by an existing control system. But if you also wanted to bring data to the cloud, you could certainly do that in this overlay manner without disturbing their existing controls.
That's really popular with predictive maintenance because it really doesn't have anything to do with the controller, the PLC, the existing control system. It's usually an additional layer of sensors, so that makes a lot of sense. Now, you probably go into this, but the Banner cloud system, I'm assuming you guys built that for customers who don't want to become AWS experts or MES experts.
Yeah, it's a software that's been around, and it's a fantastic, really a tried and true software that's been around for years with Banner. Banner's it's called Banner CDS or Cloud Data Services. And if you go to bannercds.com, it gives a great overview of the capabilities of Banner CDS. And um, one of the questions I often get with Banner CDS is, do you have dashboards? And it's like we have really powerful, easy to implement dashboards. You could use widgets to create a very a nice visualization element to your dashboards as well. Another thing that people like to have is to monitor permissions. So if they wanted to set up certain permissions for people to access the data, uh, they could they could do that as well. Another thing is that it's you own the data. It's not like there's nothing where we take control of your data. It's yours. You could use it. You could also download your data to an Excel spreadsheet, all these different sensor signals going in that you're taking into this network, and you could download it download that data wherever you need it, or you could have it set up where it's sent to you weekly, for example.
Nice.
There's even things like setting up um, thresholds and alerts. It's all very easy to set up. And the nice thing is too, is that we've got a really top class support team and that supports CDS. So our application engineers are really well versed in it. Our advanced application engineers are really well versed in setting up really powerful, scalable systems with Banner CDS. And we've got a lot of other solutions as well that use Banner CDS, particularly our wireless that I haven't highlighted in this presentation. But Banner CDS is a great software. Um, so here's another application that shows temperature monitoring. So we're using one of our contactless T-gauge temperature sensors. And from there, we're able to convert that signal. And this is just monitoring the temperature of a few critical assets remotely. So it's not coming into contact with the surface, but we're able to still monitor the temperature of that surface. And we're just converting those signals over to that unified serial RS-45 protocol and then bringing that data to the cloud. And sometimes I've noticed with applying IoT to a lot of applications, sometimes it starts with just simply addressing what are the pain points that the end user is experiencing, or what assets in their facility, if they were damaged, would be catastrophic to their production. And do they monitor those assets? And how do they monitor those assets? Do they look at the gauges of, on a dial, for example, and record it in a notepad? Or do use some other, do they check it weekly? Do they check it monthly? How do they monitor some of those critical assets? And some of those critical assets, they might be a motor, they might be a bearing, there could be a lot, but there's so many things that you could monitor with Snap Signal that make those decisions a lot easier in a very scalable, flexible manner.
I mean, it seems like it seems just like a very simple um, design that it seems like it would be great for mobile applications too, like large industrial mobile applications, like large trucks or rigs where you need to monitor certain certain things, and you could just bolt this all onto the dashboard. Have you had anything like that you're working on?
There has been a lot of discussion in that area. We haven't had a ton of applications yet, but that's an area where we see a lot of potential is in those mobile applications, certainly. Monitoring some of those assets. We have used some of our other solutions in that area. So certainly I think there's a lot of potential there for being able to deploy something scalable and also reliable in those types of applications. And lastly, just pressure monitoring. So being able to monitor things, taking a 4 to 20 milliamp output of a pressure sensor to monitor pressure of some of these critical assets. You could take that 4 to 20, convert it over to a unified serial protocol, and have dozens of these pressure sensors or mixture of different sensors going back to the DXMR90 industrial controller. From there, you're able to send that data to the cloud. You're able to send that data to a PLC. You could send that data to a SCADA system as well.
Nice.
Dust collector, so we can monitor things like vibration, the current, level of the level in a dust application, how much dust is piling up. Just a very simple, quick to deploy installation that could have serious result in serious savings and reduce downtimes for a lot of these types of end users. Even things like adding wired vibration monitoring, so bringing in vibration data of some of your critical assets or motors, for example. You could have, in this case, we're showing the DXMR90, and we have a splitter going to 4 individual vibration and temperature sensors that could be mounted on your motors. What you could do now is you could have lots of vibration sensors going to our DXM R90. And in this case, we're going to be able to set up a script called VibIQ, which will automatically set baselines for this vibration data and set up automatic alerts. So you could set up text message alerts and set up automatic dashboarding and data visualization in Banner CDS, which is something that's really powerful.
Yeah, I was going to ask about that because just having the sensors is one thing, but you need the brains to interpret the waveforms you get back. So that's excellent. So that's called VibIQ.
Exactly right. Yep, VibIQ, and we're going to deploy it, and we have it in existing in a wireless form factor currently, but we're going to just deploy it in this wired form factor in the near future, where it's going to be a wired solution using M12 connectivity. Then lastly, we're going to talk a little bit about if maybe a wire and you want to replace a wire, we're going to talk about our R70 serial data radio. And it's designed to make wire replacement easy in a lot of these serial applications. So it's simply put, it's a compact, low cost IP65 serial data radio. And what it allows you to do is extend the range of a lot of these serial networks on which what Snap Signal is based on. And so it's designed to support those RS-45 protocols. And so what you could do is you could have a cluster of sensor inputs, as you can see in this image right here on the left. You could have a lot of these sensor signals being converted over to that unified serial protocol, and then you could deploy one of these serial radios to connect to those sensors via wire consolidation product, and you could send that serial data thousands of feet across your flat factory to another serial data radio. And so what's important to note about these R70s is that they can be configured to be a master, repeater, or a slave. So you could have this configured with those dip switch settings. You could simply twist off the cover, set the dip switch settings, and then you're good to go. You're sending data wirelessly across your factory without having wires involved at all. So in some applications, maybe wired isn't preferable at a certain point. Something that sometimes gets overlooked is, I might spend $100 on $100 on a cable, but the cost to maintain that cable, the cost to install it, the cost to implement it, the cost to eventually maybe replace it in certain applications. So we have that flexibility to also combine both wired and wireless infrastructures. So it kind of makes that wire replacement very easy in these serial applications.
Yeah, I can definitely see like if you had several sensors in an area where, or you wanted to put in several sensors in an area where it would be difficult to run networking, that would be a great solution.
Absolutely, absolutely. Um, so that's kind of the high level of Snap Signal. I know it's a lot to cover, Sean. And do you have any questions? Is there any other questions? It's great. It was an honor chatting with you. I've been following the automation blog for quite some time, so it was a real honor to discuss Snap Signal with you. And is there any other questions?
Well, first of all, it was my honor to have you on the show. I really appreciate it. And everybody knows who Banner is. You guys are one of the leading companies in the industry. I guess the one thing, being the technical guy, that keeps going through my head is how do I size out a system? Like you have to have some kind of because I know there's going to be limitations in current and distance and all this. So there has to be some kind of utility or web page
Yeah.
or user guide. That's be something that's going to help me say, okay, I got 20 different sensors I want to deploy all over my plant. How many can I put on one splitter? Yada yada yada.
Yeah, so the spot I always recommend people go to learn more about Snap Signal, and it has a ton of really great content for putting together a Snap Signal solution. It's a web page we put together. It's called snapsignal.bannerengineering.com. And that's
Perfect.
a great resource for someone who just wants to learn a little bit more about Snap Signal, understand its capabilities, are interested in applying IoT to their equipment, and would like to learn more. And there's a ton of great information. There's on the software side for setting up a Snap Signal solution, we have this software called the DXM configuration software, and it could be used to configure the DXM controller. You could set up read rules to read the data from the registers and all these different sensors and converters, and then pull how it shows. And then from there, you're able to set up how you push that data to the cloud. And there's a really on that snapsignal.bannerengineering.com page, there's a lot of great content on that. And also on our YouTube channel, there's a lot of great tutorial videos that show you start to finish how to use that DXM configuration software. How do you pull data from a sensor? How do you send that data to the cloud? And those I really like the YouTube videos, the tutorial videos that show you step by step how do you set up a system from start to finish? How do you download the software? How do you use the data sheets and pull data and send that data to the cloud so you could make kind of better decisions, better data-driven decisions? And there's a ton of great content on that web page. It's snapsignal.bannerengineering.com.
That's awesome. Well, Sean, thank you again for coming on the show. Really appreciate it. This is definitely some very cool technology. And I just want to thank you for taking time out of your busy schedule and the team for taking time out of their schedule to come on the Automation Podcast.
Thank you so much, Sean. It was an absolute pleasure. Thank you very much.
Well, I hope you enjoyed that episode. I want to thank Sean and the team over at Banner for taking time out of their busy schedules to come on the Automation Podcast and bring us all up to speed on Snap Signal. Now, if you'd like to know more about Snap Signal, check out the link in the description. And of course, if you enjoyed this episode, please give us a like and a sub. Now, if you're listening to the audio-only edition, please consider giving us a 5-star review. It really helps us grow the audience and find new vendors to come on the show. And if you want to follow me or support the show, you can do so over at automation.locals.com. And of course, you'll find all of my training courses over at theautomationschool.com. With that said, I want to wish you all a very safe, happy, and healthy week. And until next time, my friends, peace.